use these laws of indices to simplify this expression. First one is very straightforward. I can use the laws of indices wherever the base is the same, A and A, so I can combine those two. And I can think of that. I don't need to necessarily write it, but I can put the A's together and the B's together and the C's together. They're all multiplied together. So I can multiply them in any order. I don't need to do it in that order, so put all the A's and the B's and the C's together. And what this is saying is, I add the powers. No power on it means it must be a 1. So 3 plus 1 is 4, 3 plus 2 is 5, 1 plus 5 is 6. So I simplified that just by adding the laws, using laws of indices, okay? Of course, sometimes fractions are involved. As we've seen, roots can be written as fractions. And we also know that negative powers means indices. Inverse expressions. So, what about this one? I can simplify this by adding together the powers. However, we could have had this like this. Look, the a to the power half could be written as what? It's a root, isn't it? The square root, so we don't normally bother with the 2 in the square root. And a to the 1 is just a, so a to the half would be square root of a. Multiplied by b squared. Divided by, or times 1 over, c squared. Because minus means the inverse. Times, what about this one? The 6th root of a. Multiplied by square root, square root of b multiplied by c. The question might have been, simplify this. The first thing I would do if somebody said simplify this is write it like that, because then I can use the first law of indices just to add the powers. So I'm going to end up with a to the half plus a to the 6th, so it's a to the half plus a 6th. And b squared, so it's 2 plus a half. And c minus 2 plus 1. So those are the powers, and I'm going to now add them together. So if I've got to add powers and the powers of fractions, the only other thing is I've got to remember how to add fractions. And I can only do that if the denominators are the same. So this equals a, well, 6 is the common denominator, so that could be 3/6 plus 1/6. b, this one, we don't tend to, because of the root idea, we don't tend to write it as a mixed number. So don't write it as 2.5. Write it as 2 is 4/2 plus a half, isn't it? Agreed? And then finally, c minus 2 plus 1 is minus 1. So now 3/6 plus 1/6 is 4/6. 4/6 can be simplified to 2/3. b, 4/2 plus a half is 5/2, and c to the minus 1. Done. And that would be simplified. I could, if I now wanted to, write that in root form. How could I rewrite a to the 2/3? Right. You're letting Warren do all the work, guys. How could somebody else, how could I rewrite b to the 5/2? Right. Wouldn't bother with the 2 because that's taken as read that that's the square root. And then times, what about this one? 1 over c. Yeah, I'm ignoring you, Warren, because you've done enough. Let somebody else have a go. Okay? That would be it. Remember we said at the beginning of this course that multiplying by 1 over c is the same as dividing by. So, finally, I could write that as the cube root of a squared times the square root of b to the 5 over c. And that's worth recognizing because divide by means multiply by 1 over. So how can I write divide by c? I can write it as multiplied by 1 over c or multiplied by c to the minus 1. They're all the same thing. And in an engineering problem, you're never going to need to do this sort of thing, but as part of an extended problem, understanding that these can be written in these different ways becomes very important. Okay. Last example before I let you have a go at some. Something like this to simplify. We use the fact that if I've got a fraction, 2 plus 3 over 6, for example, that's 5/6. I can write this as 2/6 plus 3/6. I can split and write each of the separate parts on top over the denominator. And that's what I do here. I rewrite this as x squared y cubed over xy plus xy squared over xy. And then I can simplify it. I can either use the laws of indices, because looking at the x's, 2 take away 1 is just 1x. Looking at the y's, 3 take away 1 is 2, so y squared. Or I can think of it as, well, let's cancel this x with one of them, leaving just x. Let's cancel this y with one of those to leave 2. So this becomes xy squared. What about the next term? What will that become? Something on the back. Right, because x is cancelled to leave 1's. Y goes into y squared once, leaving y. So y, yeah. Don't forget when you're cancelling down to replace with 1's, by the way, not 0's, otherwise you get all sorts of funny things happening. So all that simplifies down to xy squared plus y. Right, I'll pause for a little while now and let you have a go at the exercise 21 on page, whatever it is in the textbook, page 42.